My presentation is pretty much the blog post, which I will touch on during the whole time. But quick intro: I'm Adam. I've been doing event-driven solutions for software projects since 2008. Pretty much concentrating only that on only that since 2008. But I've been programming since the days of Commodore 64 back in 1984. I am far away here in Vancouver on the other side of the world. That's why it's nice and early for me, way before my my usual time of waking up, 11 a.m. So bear with me with these times. My schedule's all over the place, like I'm sure some of the others can commiserate. I can be found on Twitter quite often, talking about stuff, and if you find me there, so that's not me. Where's me? There's me. Can I click on my name? No. Anyway, you can find me by searching for event modeling. Pretty much everything that in this presentation. We have really good SEO for event modeling because Hacker News picked it up last September, and we made the top story, which is great. I forget if that's for the week or for a day or two or whatever, but certainly put us on the map, which is wonderful because being an underdog with event modeling and this way of looking at information systems, there's been a lot of resistance from a lot of people, a lot of groups that you would think would be quite progressive. They're progressive until it's something that they're not pushing. So it's kind of funny. There's a lot of interesting things to learn about that. So yeah, my history goes back quite a bit. I was quite frustrated with the way that information systems were put together. I was more of a low-level kind of programmer nerd. One of the first things in the first couple of years of programming as a kid was to get into assembler and hack on games and crack games. I'm sure everyone that's old enough in the 80s, especially in Europe, was familiar with the bulletin board service scene and trading wares. Well, I was one of those kids rebelling, I guess. Just having fun, really, with technology. So my passion for it is long lived. Getting into the enterprise world was a real disappointment, to say the least. Grasping for things to do things faster, such as agile, etc. It's kind of a number of aha moments in my career, and the biggest one was 2008 and looking at things in an event-centric way. And since then, I haven't looked back. There was some start to that. If you look at the about section in event modeling, we have what's kind of a history of where the train of thought kind of started, and the influential people kind of started to talk about those concepts. Organizing systems into, complex systems into separate contexts and things like that is DDD, and Eric Evans certainly started that in 2003. By that time, he was well on his way into his book. Who hasn't heard about domain-driven design these days should probably have a look. It's a very good book for organizing software systems. The idea that event-centric stuff could actually represent state was first really written about by Martin Fowler, although it's really state sourcing, not event sourcing. So you'll see a lot of parallels where this train of thought for event modeling comes through with this sort of idea that we should look at events over time instead of your typical entity relationship diagrams and typical kind of thoughts around how to architect and engineer quote unquote systems. Greg Young formed CQRS and event sourcing as a way to explicitly talk about that fundamental way of implementing solutions, specifically for high performance systems, especially where they had to perform in terms of high level of writes. He was dealing with a lot of betting systems, a lot of trading systems, so a lot of places where nanoseconds were important. So from that, however, you kind of distill the true nature of matter and things like that. I see this more of a science experiment of really looking at the speed of light to understand matter, push things to the end to really understand day-to-day objects. And I think that's what CQRS and event sourcing did, is push that boundary to an extreme as to what are the minimum things that we need to keep a functional and accurate system going. And by distilling that to its purest form, you kind of get the CQRS ES way of thinking about systems. And it's not just this pattern that people talk about. I think that's a huge mistake. We keep looking back to these early writings in 2005, 2007, even 2008, that they're highly technical. I was fortunate enough to help with some of that thinking while Greg lived in Vancouver, and we talked about this every single night almost of that entire year. I was lucky enough to contribute some of the concurrency issue to the problem of concurrency within CQRS and event sourcing, which is applying Leslie Lamport's work of Paxos to have reads and rights to be dependable and choose proper nodes that own certain entities. And further on from Paxos and these types of things, you probably heard of DynamoDB and other sort of high concurrency systems where these patterns play out. A lot of the modeling that Greg did around long-running workflows on top of these high-performance systems were discussed with, I guess, with Udi Dahan quite a bit about, they're called sagas, but they're not really. It's kind of a used term from prior art, where sagas are talking about distributing a transaction on a much more technical level across databases rather than having a long-running line of business transaction, such as booking a trip, where some of those steps are booking a flight, booking a car to rent, booking a hotel. However, I guess in recent years, that definition of sagas has been forcefully changed to really mean long-running workflows instead. Alberto Brandolini did a lot of good work on event storming, which borrowed from domain-driven design, agile, and the event-focused approach from Greg Young, and put it in front of people. I think the greatest contribution from Alberto was being able to make this into a workshop format where people are gathering and we're allowing multiple roles to experience talking about more so a problem space, and where event modeling takes that to the next level and kind of dovetails in to that is by looking at the solution space. And actually we explore problem space by throwing a few solutions out there and seeing which ones work. So we kind of skip the event storming part because we're so familiar with event modeling part. So that's kind of the history of that. You can, I guess there's a bunch of resources in case you do drop off. There's a whole bunch of videos that are intro videos. There's a whole series by Krzysztof from Poland that it's in Polish, but the code is in English, and so is the event model, where he basically does implements a system 5 minutes at a time every night. It's quite good. Some of my introductory talks from before, one with Roy Osharov, who I'm sure a lot of you know, who wrote test-driven stuff, test-driven books, Art of Testing, things like that. Usually we have workshops. Right now it's kind of in the air because of the situation. I have some example code for some simple things and some stickers if you guys want to print them out for your laptops. That's cool there. And basically everything that we want to talk about with within event modeling is the what is it article, which is the one that got a lot of traction on Y Combinator, or Hacker News, if you will. The introduction to my talk, it can go either way. A lot of my initial, once we penned what event modeling really is, a lot of my talks back then focused on the human psyche when we think about systems and specifications and implementing them. There's a few interesting things after doing this style of development for a long time that emerged as kind of takeaways. And one of them is seeing how the human mind is really evolved to think in stories. And so one of the things you'll notice with event modeling is a left to right storyboard type of layout. This is really it. Event modeling is supposed to be something that you can explain very simply, very fast. And for this reason, there's only, three. You can go as low as two types of things that you put up on the model: the events and the screens that you see. But to be more elaborate and show some other intricacies and some other be more explicit about some things, you introduce the idea of a command and a view, which is basically representing input and output to the system. Those key pieces are put together through only 4 patterns, and that's quite important. We don't want people to have to study entire books to understand what this is. We want people to read this article and then get going and practice it, and at the end of the day, understand what's going on. So the reason behind that, well, that's basically, first of all, we need something simple. We can't have UML diagrams with UML diagrams are 7 types, and they don't really play well with our minds in terms of like how humans think. So the first couple of paragraphs in here are introductory paragraphs that could themselves be entire talks on the subject by people that have way more experience with this. One of the things that we kind of don't pay attention to is how automating information systems started, and it really started during a time that we moved from vacuum tubes to transistors and integrated circuits. That's when systems became reliable. Those vacuum tubes burnt out, and there were slow systems. I mean, there was just adding machines maybe that could have been used for. Let me just mute my. I always forget to do something before we start a presentation. Anyway, so in that history, when we got the transistor, that really skyrocketed what we could accomplish with automated systems. Now, information systems existed for thousands of years. They were just pen and paper, but the same things were being done with them. Now, why is that important? One of the problems with the advent of the transistor and having these fast systems is that while we could process things incredibly quickly, the storage side never had the same type of increase in productivity or efficiency. So the tape drives were still the same tape drives. The backup spools were still the same backup spools. Now they had to support all this influx of information. So in the 50s and 60s, while we were putting people out of work that had desk jobs to do some of this stuff manually, the storage for those things was at a premium. It was $1 million to buy a hard drive that stored 10 megabytes in 1956, I believe, and it weighed a ton, and it was the size of a room. That's 10 megabytes. It's crazy, but you could run on a couple of those, you could run a multinational insurance company. So how they were able to do that, obviously, is by not repeating data. And I think this is the advent of object-oriented programming and some of the paradigms of state-based focus in automated systems, is that you really did not have the luxury to store everything. And this really interesting thing about human memory was lost in the world that we lived in before to the world that was now automated. Human memory is how we built civilization, from stories being told about around the campfire in a cave somewhere. Before written word, we were able to pass on knowledge, and that was basically being able to pass on memories to our children and grandchildren. And so as the first species to do that successfully at scale, there's crows and other little societies in the animal kingdom that this happens on a very limited scale, and I'm sure given a couple of more million years, they'll do the same thing. But for now, we're the only species that we know of that was able to build up this knowledge base, and so that's what's built up society, is our ability to retain information in this kind of interesting way, kind of from just how life works. Really, if you look at genetics, it's a limited number of genetic sequences, yet they produce incredibly complex, chaotic patterns, fractal patterns to build the wing of a butterfly or something. So there's inherent nature to to humanity and life itself, where we are able to fill in the blanks. And human memory is kind of like that. We take keyframes, and we don't really remember every word of Hansel and Gretel or any other story, but we understand what has to happen. We understand the end results at certain points, and we can recite that same story many times over with different words, but accomplish the task successfully. Our children will be happy. They'll get the expected happy ending at the end of the story, that they're getting the same thing. And that story has been the same for thousands of years. Some stories have, the Bible and all this. So where I'm getting to with this is that we don't do this in our traditional initial decades of automated information systems, because we could only talk about very technical things, because that was the problem space and that was the world that we lived in. However, if you look more recently, behavior-driven development and specification by example is one of the best ways to take how a system's supposed to work. Talk about stories. We have user stories and things like that explain what's supposed to happen. And these examples are really powerful because they are, again, how our minds work. And so if we find something that's very congruent to what's going on in our minds naturally anyway, then we have an advantage of being able to take that work back with us and actually execute it as to how people thought about it before. So human memory is quite important. You can read about this in the first 3 paragraphs of event modeling. By the way, you can follow along. Just Google event modeling. I use 1L. It just looks nicer on stickers, and it's a shorter spelling. The double L version of modeling is a little clumsy for a brand. So hopefully this is something that'll catch on, and spelling modeling with 1L. So I already covered simplicity, that the event model is after simplicity. One of the key things that isn't in this article that I should probably add is it really, I think one person framed it best. Event modeling on purpose removes a lot of the how. It focuses on the what and the why. And that gives you the removal of 90% of what you would hear is documentation that can never be maintained, or clumsy UML diagrams that no one actually references in their day-to-day work. Because event modeling is so small, it is something that you can reference every day, and it's only one picture. For your entire project or set of projects, or even an entire organization, it's one blueprint, like a house. And we can do that by concentrating on the things that matter and ignoring the things that don't. And the sad truth is that it doesn't really matter how we program. In fact, we'll get into the polyglot approach, where we can take any stack and mix it in with another stack because of how well defined our state transitions are. More on that later. I do want to make sure that we have, I'm hoping I have that Miro board somewhere here, because I do want to touch on that. Yeah, I think I do. We use Miro for online collaboration, but there's also Dryo and many others. So I have a touch screen, which is easy to manipulate these things. This is from an exercise that we're working on online, so you're free to join. We have a meetup to kind of go through and use this event model to actually implement something. This is a time tracking system for contractors, etc. So I'm sure it's quite applicable to a number of you, but it can also be used internally for employees and that. But it's nice to see it event sourced, etc. So what we usually can, as you can see, the event model can be sliced up, and certain state transitions can be assigned to a specific person that's working on something, along with the screen. I'm jumping all over the place, but I really want to get through this quickly, quicker than usual, so that we can get into some discussions and get some questions. Here's kind of what we want to be able to do. Not that we would do it. We do it as an exercise. Simply because if we know that we can do this, we know that we don't have to worry about a risk if we need to add, let's say, just one more stack to our solution. So because each state transition is quite separated, by the way, this is an implementation that's done in event sourcing, although you can do event modeling for traditional systems, and you can do some of this stuff, just not as much. So you kind of lose some of the benefits of having your transactions embodied within events that are stored on a ledger. That's a separate presentation. But in any case, this particular exercise kind of allows you to do, a .NET container that takes care of part of these screens and endpoints. We can have some Node.js that adds some other functionality. We can do some more time tracking done in Golang, and PHP for some of the timesheet stuff. So as you can see, there's little notes. This is how you identify hotspots on your event model. Usually we don't bother with this diagram, by the way, in an event model. This is just an instructional one, so we can show and play around with some of these diagrams. This should be your only way of communicating. It essentially looks at the different. We really should have examples. It should be Joe, Mary, Joe the product owner, Mary the designer, and Mike the programmer, and then whoever for the admin. And as we go through time, we show the exact screens that they see. These are not filled yet. These are just placeholders for now because we're in the middle of developing this. But some of them are filled out as to what information will be on there. And the important fact of this is that you have what's called information completeness. That means the example data that we have in here, you can actually trace through and see where it came from and where it's going to. So there's no piece of information that doesn't have a source and a destination. And it's kind of a way to look at the boundary of systems thinking. So if your solution is bounded by a box of everything that you're responsible for, you should be able to identify all of the contracts in any kind of systems like thinking as to what's going in and out of your system externally, but also your subsystems inside. And this is where we have the swim lanes down here, where we can say that certain state is stored in different subsystems. For example, we can have the time tracking aspect in one system, and we can have the user registration and profiles and things like that in another, as an example. Here I use the example of the hotel, which a lot of people understand how it works and what happens when you check into a hotel, etc. And that's it. Here, we talk about the importance of the wireframes. The UX UI always gets we forget about it when we're dealing with technical concerns. So UX and UI is at the forefront of event modeling, so that everyone has a reference point to where we are at in terms of the story visually. When I'm in the middle of a complex workflow, I can see by example what that workflow is doing underneath, how it's changing the state. And then we divide this up into the pieces that we talked about earlier, such as the commands. That this is how the information gets into the system, and events with views that populate information, screens and things like that. That's how we have output in the system. It's important to do it this way because it kind of embodies the empowerment, the ability to change something in the system with the ability to be informed about the current state in the system. And every system that you talk about has these properties. They're usually 99% of them are built on input and output. So this is at the heart of event modeling, is to show those pathways, but not just as a bunch of UML diagrams with class interfaces and a list of methods. We want to see this over time to understand what's going on. Think of this as the most useful diagrams you could ever have out of, I would say user story mapping, UML, etc. Throw away all the cruft, the uninteresting stuff that doesn't help you at all. Only keep the good stuff, and we kind of end up with an event model. This ends up being quite an awesome blueprint. Any questions so far? I know there will be more. Maybe I'll get through some of this other stuff. So the two complex patterns are translation and automation. And this is how we show two patterns for getting automated input and output of the system. It really is only two patterns for input and output, but we do elaborate on input and output that's automated for us, and it's not the actual user or an automation doing that. A user or a user that's doing something is usually pressing a button on the screen, or there's an automated process that's sending the command for us or something like that. So that's the input and output. So the automation is interesting. Let's say in the hotel example that I go through here, we have some GPS coordinates that may be quite noisy. We went through a bit of that in the first presentation about logging things that are just, happen too often, and we want to just grab things for our own purposes that are aggregates of that. So in this case, a real world example would be getting updates from users, hotel guests' phone, where the GPS coordinates are given every 5 seconds or a minute or whatever, and we want to have an automatic checkout process for them. So if we see their GPS coordinates more than 100 yards away on the checkout day, we just send them an invoice over email and that kind of notification. So that's kind of one of the features we want. But when we're specifying that feature, we don't want to be giving longitude and latitude coordinates for our tests. We want to be using events that are talking about a user being outside of the grounds of the hotel, right? User has left the grounds of the hotel. Therefore, we can kick off some automating process or do other things. In other words, the translation here is these fine-grained events of longitude and latitude. There's some translator or interpreter that only emits an event when that threshold is crossed. And so we can show that to business and to implementation. This should show developers, testers, and the business that, yes, this is how this feature works, and this is what people see across the timeline of using this by example. The other way is how does that actually, so that's information coming in, that's GPS coordinates coming in, external information coming into our system that's not directly user provided. And here is information coming out of the system that's not triggered by a specific person. Now, these are automations that are done by a cron job or whatever. And we don't use queues or anything like that because that kind of confuses people. I have to-do lists, which is kind of a generic thing that anyone can understand. So I have a to-do list of sending email notifications to all these people about, sending them their invoice about their stay, because they're the ones that just left in the last 5 minutes. So you can imagine a process that queries a table every 5 minutes, and whatever's not done on there, it goes and does that. And then once it's done, it marks it with a checkbox as it being done. That's how we represent anything that is automated. And if you look at even the network stack where you have packets being sent across the network, that's a piece of memory that's sitting there, some sort of a buffer that then the network card picks up at some level and actually sends those patterns over the wire. So no matter what, information is sitting somewhere and it's going somewhere. And that's all we're doing here, is we're showing by example what that information is. And that's the way that we can, again, with the way our minds work, that's the way we can reliably create systems. So if you fast forward to the end of a project, and also along the way, you can say, is the system that we've implemented, is it treating information like this? In other words, if we follow the inputs and outputs that are in this event model, do I actually have this behavior? Do I see these screens in this order? Do I see that information coming up? So it's a very clear and crisp event specification by example on the aggregate. And it works quite well. We do break out certain pieces into, I'm not sure why this is here. Should be here. Okay, so this is it's not meant to be read. This is just an example, but what happens, the devil's in the details. You've shown a happy path here of what's happening left to right, but we have a lot of if statements, we have a lot of branching. What happens when the data is in this form? You can show those by breaking out certain scenarios. So in this case, we have this, oh, this is in the wrong place too. Someone changed it. Anyway, this is supposed to be here. So if we explain an intricate view of data, which we kind of went over in the first presentation, and we want to see how that evolves and specify it, we can say, what does it look like by default? Then move one and say, what does it look like when the first event happens? And then what does it look like when that first event happened and then another one happened after that? And so on. And we build up this story, and these translate to your unit tests. These should directly translate to your unit tests. This is the best example in my entire career of business being hand in glove with the implementation. It's so tech agnostic that it actually frees you up as a developer to do whatever you please and not have anyone breathing down your back. Because as long as the state transition is correct, this event is stored. And it's met in SLA, you can specify some timelines and actual time increments here. So if, you know, some of these, let's say this automation here that we have, if that has to be within, you know, 2 seconds, I can write down 2 seconds on this timeline to say that, hey, these things were marked to be done within 2 seconds. It's not happening like that. Go back and fix it. Because we have this pretty neat way of planning out exactly what's going to happen, we remove all the rework. So we take out all of the pieces out of the test-driven design cycle under refactoring. In other words, we give very definite scope to what is up for grabs when you refactor. And that's quite important because the real benefit of event modeling is removing rework, which is the reason why 99% of our software projects are nightmares if left unattended or any other things. Or just even if you are very disciplined, you're still going to have quite a lot of problems. And I show that here. This doesn't just work for event-driven systems. It works for traditional ones. So these are, if you want to, first of all, if you want to do a workshop like this, I actually have some examples of, oh, right, a little bit more about me. So there's some examples of, all right, there's Eric Evans visiting our company. This is kind of what we do live with clients. It can last an afternoon, a day, or a week, depending on how much you need to plan out. But it's a highly interactive, multiple role process, so everyone has a chance to say that this story makes sense or doesn't, or it's missing this information, or could we do it another way? Why are those screens not showing that information? These are some of my hobbies, and bears live where I live too. So I forgot to show that at the beginning. All right, back to this. If you want to do one of those event modeling workshops, the 7 steps are outlined here. We simply go through talking about brainstorming all the different events that could happen. Let's say we're doing this hotel system. We would have people checking in, checking out. We had reservations that are made online, reservations made by phone. There would be a cleaning crew that would have to have coordination about when each room is cleaned. All of those things are events, and all of those things contain data, and we can follow where that data goes in a little bit. But for now, we put them into a timeline, make a plot, see if we can make these events make sense, like a story would. That, yeah, this actually does represent a year in the life of this company if we were doing hotel automation. This is a good representation of an example customer that's managing their hotel with our software. They're doing all these things, and we can actually see these events happening in this order. Steps 2 and 3 are interchangeable depending on who you're dealing with. A lot of people are more visual. We can tell the story with pictures. So we can say that these are the screens and information on those screens and information that people put in by example over time. So I can show that, you know, these are the screens that the guests see, then the hotel manager sees this when they show up to check in. This is the screen they see on checkout. And I can, on a timeline, show that as an example. This is our happy path, but it's the backbone of what we're after. We want the happy path, so why don't we make it important, right? Everyone's like, well, what about the little details? We'll get to that. Number one thing is, what do we want the system to do? Let's keep that vision and make sure that we're coding around and solving the problem in and around making that happy path a reality so that we do have the vision fulfilled. Later, we identify all the inputs. That's quite important, as you know, I pointed out in the beginning. Different aspects of the system can scale differently. If you have a high intensity input driven system, these blue boxes might be very important for you, and you'll have different ways to arrange your swim lanes later to where you're going to store those things. Then we look at the outputs, the green boxes. The green boxes show us where we aggregate information. It could be a report, a sales report. It could be just information on a screen, or with the idea of these little processors, there are to-do lists that they work off of, such as who to send emails out to for notifications, and when to call a payment provider for processing a credit card or anything else like that. Now we organize things. So one of the things that Mel Conway talks about is how teams kind of push the actual architecture, because if you have two teams, you'll end up with two subsystems. That's just kind of the way people work. So why not get ahead of that curve and actually have people talk about what that's going to look like, and if we can, during this event modeling session, make some swim lanes to show that there's going to be a room inventory subsystem, there's going to be a payment subsystem, and there's going to be a registration subsystem. And you have 9 people, you might have, you know, 3 people per team, and they can say, I'm interested in working with these 2, and we're going to be doing the payment system. So it's quite nice to explicitly see where those divisions are and how it actually plays into the workflow. So some of the things in one swim lane might actually be just near the end of the workflow, such as payment in the hotel case, and others, which is customer acquisition, may just be at the very beginning. So there's sometimes you'll see these interesting patterns of stair-stepping through the different systems as you go left and right through your workflow. Yeah, so project management, this is really cool because, as I already showed here, we can assign people to work on a specific part of the workflow. And in there, we include the UI, storing of the state, changing the state, or viewing the state, and processing that. So these, if you draw vertical lines through this diagram, it's a very good contract as to what your preconditions are. And the line on the right of your slice is what your post conditions are. There's very little argument as to when success happens. And the nice thing about this is, if we look at the other article here, I don't really mention it as well here. I do go over it. But the reason that traditional systems keep costing extra and extra time to develop anything is because of the rework, the lack of those slices. I'll show you how that works in a second. The traditional system usually is greenfield when you start, and it's beautiful, and everyone's doing 10 features a week. It's fun. Everyone's happy on a Monday morning. Then fast forward 6 months, and what do you have? You have a death march. Everyone's barely able to grind out 1 feature a week and steps on multiple people's toes. Someone's trying to refactor some part, and you went in there to get your stuff done, and now you're negotiating with, do I upset this person just to have this out in time? Everyone's familiar with that disorganization and just the complexity really going through the roof at 6 months in. We don't want that. An event modeled system finishes as fast as it started, and there's a cadence to that. It even actually does the opposite. We find that because we start with the most complex slices that are interesting to the business, the initial work is actually what takes longer. And the stuff that we leave for last, such as log in and log out, and maybe some boring sales report, that stuff gets done later, and it's easy. It's kind of easy money. You just, the end of the project is where you're the happiest. Not that you're unhappy at all throughout this. We have quite the opposite experience of traditional development. So yeah, estimates. This is awesome because what you can do as well is really get a good velocity empirically, seeing how long your team is taking to do any particular slice, and then work out basically a cost number associated with your projects. And the next project that you do will use these same building blocks. So you kind of can draw a conclusion and say that, we need $500,000 in 5 months for our team to complete this. And you're actually backing that claim, not through some story point analysis and, all this kind of stuff that's really witchcraft, in my opinion. you're actually basing it on past performance of these people working on things that are explained this way. So it gives really, really good predictability to how fast you can develop things, etc. And think of, going back to the previous presentation with logging, this is business activity monitoring, right? Built in. You can plug that into that Azure stuff right away. These events have things that the business cares about. Think of the criteria and the dashboards you can make off of this compared to the traditional system where you have to sprinkle it in the code, right? Again, because this doesn't concentrate on the how, it actually concentrates on the what. So what do we see on the screens at the very start of any interactions to what is getting stored in a database down below. We don't care about how fancy your if statements and for loops and what algorithms you used. It's boring stuff. It's yet another hotel system. It's yet another insurance company. It's yet another whatever. Sure, there's snowflakes onto themselves when you compare them, but each snowflake is made out of water, and these are the molecules of water that we're playing with. So we can actually get that count to be accurate. What else do we have? I just want to get through here. Oh yeah, guarantees. So anyone that's doing one of these slices, if they screw up, they have to fix it for free. You've given them enough information to show how it's going to interact with the rest of the system. If they screw up, they got to fix it for free. You can pass that on to your client, right? And we've had the best projects done this way because they're predictable. We de-risk them. They're going to cost this much no matter what. We're not going to, in the 11th hour, say we need more budget another month. I mean, that's just the worst thing, and that's just how software is done these days, and it's horrible. When we don't do that at all, we can't afford to. There are, different clients that we still look at where they're working on infrastructure, not actual features, and then you just have to do time and materials. You can't do this fixed price way. That's different kind of work, and it's actually a cost center work, right? Anytime you're working for infrastructure with the client, it's really, they're not adding features. They're maybe polishing the existing features to work a little bit better. It's kind of getting dubious. It's nice to be able to have statements of work that are separate. Separate statement of work for actual functionality, separate statement of work for all the infrastructure that you're going to spin up to make things work, right? They have very different dynamics, and they have a hugely different impact on the system, right? Features are things that their salespeople can sell immediately and therefore get money so that you can do the infrastructure. Both are needed. It's nice to be able to draw them out like that. Change management is awesome. You take a you take a screenshot of this or copy this whole thing, paste it down below and say, this is version 2. We've changed this, that, and the other. You can analyze which slices are already done and you can reuse, which slices have to be replaced by new ones, etc. So you can do a very easy change management. It just comes right out of the box with this. No giant documents and things that, 99% of the documents you're using right now, even agile practices, they all go out the window. I can't remember the last time I worked in a place that had a stand-up or anything like that. I just don't have them. Don't need them. We know exactly what's going on because we have a blueprint that everyone's using every day. Legacy systems. We can sidecar things. You can show that, your cruddy, nasty stuff is coming in this way. Oops. I got it really. Firefox doesn't do zooming as well as Chrome, unfortunately. Anyway, yeah, we can sidecar a solution. So in this legacy code example, we basically want to, I think I'm using Sugar CRM in here, where we don't have a profile picture capability, and we have a bug with the way that email is stored with some extra space or something in that field. So we show how we can listen to the legacy system, translate that into something we can use, such as, you basically take a snapshot of the database, register a user, take another snapshot of the database. What's the difference? Okay, this legacy system has these crappy things it did to 10 tables for some reason when it registered a user. On the screen, we were only interested in these results. So therefore, my translation should extract only those pieces, and then we can do our traditional event model here. And then if there is a bug fix, such as this, this duct tape that we're going to put onto the system to correct those emails, we show exactly which tables it updates in the system when we adjust the user. So the new system is fixing that. And here's an extension. Here's how we store a picture of someone. The existing legacy stuff doesn't store a picture for a profile. Here's how we do that. And funny enough, that's exactly how this polyglot approach here started. We need to have these routes going to the legacy system or the new system. Can everyone see how that would work? That the legacy system can be just contained in a box in a VM somewhere or a Docker container. And then for specific routes where we want to add functionality or replace a buggy piece, we can have it as a sidecar. And down below, we can have a database that the legacy database that's also updated by that. So that's how you free yourself from having to swim through garbage code. You know, that's 5,000 lines long, by forgetting about the how, just looking at the start and then what happens at the database. That's why a lot of this legacy stuff, when you look at it from event modeling for traditional systems that are not event sourced, you're looking at the new article, Event Modeling Traditional Systems. And Fred Brooks nailed it way back then. He saw this, that we didn't really have anything special. We only had what is in the system when we turned the power off. And that's what's on disk. That's why he said, you know, show me the tables and I'll understand what you're doing. Don't, you know, flowcharts and all that, you just get confused. They're branching and all that. It doesn't speak to you. It says, show me your flowcharts and conceal your tables, and I shall continue to be mystified, right? And so we can use this with event modeling, and we still keep events. We don't use them in the implementation, but it's important to show events still, because we keep what's in the user's mind, what their intention was, and we can see what the mismatch is with the actual implementation of what we can store. So if we look at, you know, going through and starting a little project, you have an interface and you start to build events, but then you have to have a table. I'm sorry for the size of this. I'm going to try and zoom in. I think I'll just zoom in with my computer instead of. All right, everyone can see that? Hello? I'm not sure if anyone's actually muted or if I'm talking to myself at this point.
Yeah, I can see that. Fine.
Okay, because I can't see the Zoom anymore, so I don't know if if we're all offline. I've just been talking into nothing for the last hour. Anyway, so the first, the second step here is, hey, there's a user table which captures this registration, right? And then, well, what's the next thing in the time sequence here? Well, we definitely have a select statement to show some of the information we want to go and verify this, right? So now we actually show. Notice I'm reusing the command colors and the view colors to basically substitute for inserts and for reads in this case from that table, but we can see which information we're using to do that. It starts to show you how your data is actually binding functionality together, right? And as we continue on, let's say we have an email verifier. This is a very important piece here because it shows explicitly with traditional systems how you can flatten that cost curve, which is the bane of all these software projects. So you have an email verification which was going to ask for this verification code. Currently there's a none, but we know that this little verification email is going to send one. So it's going to update this row, and it's going to update the verification code so that, in the next sequence, when the person actually clicks their code in the email link that they got, they can, search if it matches. If it does, then they're authenticated, right? They're verified. Notice that a new column appeared, right? When we were doing the first part, we didn't know. This is where Agile fails. We didn't know that we're going to have in our implementation the need for a new column. Now that we've modeled it, we do know that. So if I was to start to implement right now, I would have open close principle satisfied. I wouldn't have to come back to the register functionality to make sure that the verification functionality is working. If I don't have the event model and then just taking the next thing off the backlog, which is this beautiful way of like freeing us from thinking, right? Keeping work in progress low and all this other crap. That's the rub, because the rework starts to pile up. If we only choose this ignorant approach that Agile pushes so damn hard down our throats, we end up in this scenario. If we finish an entire event model, we have OCP. There is no reason why we need to go back and change the registration functionality when we're doing the last few stories for the whole project, right? This is very key. And the reason that this didn't work before is because we only had UML and we had all these scattered things for different things. Event modeling is for everyone to look for the concerns that every single person may have. What is the UX question? What is the testing question? What is the development question? What is the product owner question? What is the CEO question? The event model has to answer all of them, and it has to be done in a very simple and fast manner. That's why it'll get used. And if you do that, then you get this cost curve. The only way that this was possible before is by having mountains of stupid documentation that no one gave a crap about. Here you have one blueprint that tells you what goes where. And now just start filling it out. Get to work. That's what event modeling is about. So it's small design up front. And if you're doing this traditional stuff, it shows you where you're deleting data, right? It says, oh, these events happen. We don't store them, but it's causing this update here. I can show you here through these swim lanes where you're wiping out data and where you're going to need to do either a history table or restore a backup and see what happened and all this other garbage, right? People that do the event sourcing way of things, their QA departments and their customer service departments serve the developers. Customer service actually calls up a developer. It says, you have a problem with the email notifier, please go fix this. Not that there is a generic bug. It's totally changed the way that companies work if you do the event modeling type of way. Now, that's not to say the traditional model couldn't be helped with this way, where you can actually trace through to see why a certain column has a certain state. I don't want to swim through code to answer that. That's garbage. That's like employment insurance for the programmer. The only person that can tell you is the dungeon master in the corner that's been here for 12 years and knows exactly why that damn column is in that state. No more of that, right? We need to see why that column is in that state, and an event model will show you that. And the person that refuses to do this is probably afraid that they're going to be redundant. For good reason, they should be. Yeah, so that's about it. I'm going to have a couple more things. I wanted to share one more thing here. Well, let's just wrap it up and maybe it'll come up in the questions. I know if you probably have questions about these grandiose claims. Vancouver event-driven meetup happens more or less here and there. It's kind of been changed because of the situation, but currently we're working on this, which is a time tracking system. So you can follow along and code and update the event model to make a time tracking system a reality, make it open source, make it event sourced, provide different technical stacks for implementation as examples, and be able to replace each slice with a, hey, you think Ruby's better for that? Awesome, go for it. Stick that in and glue it together in this manner, and the system will still work. So this is a fun thing that we're doing to just have a real project to work on. Because I want it for, for my company. I want to use a time tracking system that's event sourced and that's done with an event model. And hey, dog fooding your own stuff. So fun. So that's something that we're doing. I'm going to schedule it for Friday, so it's not here yet. This is the last one. We had the part 2. The first one is recorded and put up there. The second one, the recording is being finished right now. It's going to be up on YouTube soon. But then on Friday we continue to develop it. I am on LinkedIn as well. We have a really awesome thing that got mentioned by the Prime Minister of Canada for the project they're working on with our client. All event sourced, all event modeled. So it's starting to get noticed, which is really cool. And my company is Adaptech. Ignore the workshops, they've been canceled, but they will be back as soon as we can fly again. About us, The crew's awesome. Greg's helped a lot of good people in Poland. So we have people on the other side of the world helping out. These guys are day-to-day builders that do awesome stuff. So really happy to be working with them. I hope you get to meet them online. They do their presentations too. I'm sure most people know Greg Young. He's the guy that's behind all the CQRS stuff and event sourcing, and none of this would be possible without him. So many thanks to what he's started in this world, and it's helping everything. Yeah.